Good morning. Good morning and welcome to the 2025 TechNet Cyber Conference and the Signal Innovation Showcase Series. I'm George Seifers, Editor-in-Chief of Signal Magazine. We're glad to see you all here. Our first guest of this series is Connor Winveen, Solutions Engineer at ChainGuard, who will be speaking about AI applications. Connor, welcome. The floor is yours.
All right, thank you, George, and thank you all for showing up and rocking with me for the next 20 minutes. We are breaking in the Innovation Showcase here, so it should be a good time. We're going to be talking about an AI applications journey to production. I'll caveat by saying this isn't a true story. This isn't an application that made it into a federal production environment, but we're going to do a thought exercise of what it would take to get an application and an AI application into a production environment going through the ATO process. All right, so to tee up what we'll be talking about, the application we're building today, we're going to be focused on open source software and securing the containerized applications. So if you guys are familiar with containers or cloud native microservice kind of architectures, that's how we're going to be building our application today. And the reason the focus is around open source software is if you look at the graphic there at the bottom of the screen, kind of the classic software development lifecycle visual, 80% on average of our code base is open source software. And actually the AI application that we build in this example is like 99.9% open source software. It's just like 100 lines of Python code. Everything else is open source. So if we can solve the security problem for open source software, we make life a lot easier to solve the overall security problem for our application. We're going to be building a retrieval augmented generation AI application. So that's a mouthful. I'm just going to refer to it as a RAG app moving forward. We'll talk about what that does. And then, so we'll put our developer hat on for that exercise. And then we're going to put our security hat on and talk about securing this RAG app that we just built. All right, so this RAG application, here are our requirements. We have our developer hat on now. We get tasked that a program wants this outcome. We want developers to be able to chat with this RAG application so that it can help them build secure containers. And we have 3 top-level requirements. So it needs to work in an air-gapped environment, can't be internet connected. It needs to understand DoD container hardening requirements. So that's kind of the augmentation piece of it. And we need to be able to pass it Docker files so it can analyze our applications and give feedback for non-compliant issues and suggested fixes. Okay, so we've got our requirements, and now we're going to put together just kind of like a rough architecture that we think technologies can come together to meet the application's needs, which is what you're seeing here in this slide. So the kind of workflow here is from the user experience. So we want the user to be able to chat with a ChatGPT-like feel. So they'll open a web browser, they'll type in a prompt, maybe they'll drop in their Docker file, and then it sends off into our RAG application that does that augmented generation, AI generation. And what we're feeding it is, so the core of it is this Python app in the middle. So we're gonna build some Python code. We're gonna pass to our Python application some DoD container security guidance. So I fed it DISA's image creation and hardening guide. I also fed it Iron Bank's acceptance baseline criteria. So Platform One has a thing called Iron Bank, which is a source for secure containers, and they put out guidance for what you should be doing best practice-wise to secure containerized applications. So our Python application has that context for what container security looks like to the DoD. So when our user asks a prompt into the web browser, our Python app will look for matches in those documents. So it's augmented the prompt with DoD guidance, and then it feeds it to an inference engine, which is OLLAMA, and then a large language model. We're using Gemma 3 in this example. So if you just asked OLLAMA and Gemma 3 that question, what is Iron Bank, or what is DoD best practice for building containers, it would give you some pretty garbage answers. But with our contextual documents, it's quite good. Okay, and then show of hands, who in the room has built a container before? Okay, a couple people. So we're going to simplify it, but this is kind of how you do it. Just a couple files. Docker file, that's the thing. It's a set of instructions that tells you how to build your Docker image, which when it runs becomes a container. The main.py, that's where all our logic, our Python logic comes from. Again, it's only 100 lines of code. I'm not a developer, and ChatGPT helped me build this thing pretty quickly. And then we have a Docker compose file that you saw 3 different kind of core technologies we're using for this RAG app. So OpenWebUI, we run it out of the box. Ollama, we run it out of the box. And then the Python app is the thing we're building ourselves for the logic. And the Docker file, we're building a Python application. So we're going to start from, the from line tells you a base set of software that's going to have the things you need to build and run Python code. So we made a convenient choice. We said, I'm going to grab this Python base image from Docker Hub. It's going to have everything I need to build the application. Then you copy in your source code, you install your dependencies, and then you run your application. So that's in its simplified form. This Docker file is a set of instructions that helps you build your container. And then we run it, and it looks like it's working great. So here's just a snapshot of our chatbot. You can see I passed it a Docker file. I asked it to give me specific sections of if I'm not compliant, where that guidance is missing the mark. And you can see I've got a couple responses here where using the latest tag is not best practice for a base image. We're not using a non-privileged user. So we're getting some feedback from the chatbot. From a functional standpoint, it looks like we hit all of our requirements, which is great. Okay, so development team, we checked all the boxes. We handed over to the security team. In order to get to production, we're going to have to go through a security assessment. And very likely, you're going to have to at least show evidence in these kind of 4 bullet points here. You're going to need to scan it for vulnerabilities. You're going to need to show that it's meeting container hardening requirements. You're likely going to have to hand over an SBOM, and it may get assessed for what's in that software bill of materials. And then you're going to need to use FIPS cryptography. You might need to hand over STIG evidence as well. So if we take a look back at our application that functionally works, we can see it has some security problems. So when we scan it with a container scanner, there's 782 known vulnerabilities, or CVEs. 5 of those are criticals, and 103 of them are high. So those are definitely going to need to get assessed. There's almost 1,000 packages, 3.2 gigs, which might be expected for AI applications. There's a lot of heavy things that run in there, but we'll take a closer look at that. We're not meeting hardening requirements, as we can see by some of these callouts from our chatbot. And then we're not using FIPS cryptography as well. Okay, so let's double click on how we're building this application again. So if we look at it kind of layer by layer, that from line, that choice we made for convenience, I'm building a Python app, let me grab a Python image from Docker Hub, pulls in all of our known vulnerabilities. So that thing starts at a gig. It's got 432 packages and 782 CVEs. All our AI kind of dependencies and whatnot, our source code didn't pull in any known vulnerabilities. So let's now put our security hat on. Our options to try to get this thing in production is we can assess all 782 of these CVEs and see if they're a real threat, or come up with a plan to patch or fix, or say, this is not exploitable, we're accepting the risk, or whatever. What we noticed, panic at the distro, that was a tagline that I didn't come up with, another catchier engineer than myself did. So all these CVEs are coming in from Debian packages, and Debian's a Linux distribution that packages up a lot of software. So if we look at one of these critical CVEs, as a security expert, we're probably going to start with the criticals. We see this package zlib has a critical CVE, and if you look at the CVE-2023, the way they write these identifiers is that number represents the year it was identified. So it's been around almost 2 years, but still exists in this Debian package. And if we look closer at it, the fix was available upstream almost immediately. So that snapshot where it says zlib 1.3 release in August 19th, 2023, if you just build or pull in that release version, the CVE goes away. Upstream fixed it. But Debian, like a lot of other large Linux distributions, maintain tens of thousands of packages. Their priorities go toward stability. They have a limited amount of resources. So it seemed like probably a low probability that this was possible to exploit. So they deprioritized it. But from a security standpoint, we still have to assess the risk, right? And if you look at the criteria for this exploit to be possible, it seems like it might be for our application. We have a user input. It's a chat prompt, so somebody might be able to ask our AI to use this zlib file to compress something in the background. So might be an actual exploit in this case. All right, so our choices are to ask our development team and prove that it's not exploitable. We can also see if zlib is even required for our application. We can try to remove it. Or we can try to rebuild zlib from source and then introduce that instead of the Debian package that's in there. All of those things require engineering work. And what we're going to talk about is a kind of better approach to, instead of assessing all these risks, just start from a better point. So here are some options that we can use in that from line in the Docker file. So the kind of far right bar is pulling from public upstream sources. The bar to the left of that is for Iron Bank, and this is for very popular container images. You can see that there's still a lot of CVEs in both those options. Iron Bank obviously better than upstream, but the bar that you see all the way to the left there is if you can get all of those packages that those images need straight from source code, the CVEs go away. So the fixes exist in source code. If we can just tap into the latest versions of those things, our CVE problem goes away. And that's kind of ChainGuard's approach to how we build container images. So I know we've only got 20 minutes here, so we assessed one CVE, and we definitely don't have time to assess the other 781. And on average, federal programs spend 15,000 hours on CVE management, so a lot of time spent here. All right, so let's try to fix our application. The intent with this one is we don't want the security scanner blowing up with security findings. We want to get away from that kind of security hotline bling. So we're going to cover all these kind of 4 check marks that make our guy Drake happy here. Okay, so here's our phased approach to go from how we built our application with that first Docker file to a Docker file that checks all the security boxes. So the first thing we did was we picked a better base image. And all that took us to do was change one line of code. So that from statement, instead of pulling from Python latest, we pulled from ChainGuard's Python latest -dev image. So that has the stuff you need to do development. But we still see that there's a couple things that might take some time from a security standpoint. So our CVs are low. We have 2 lows. It's hardened, so if we pass it back to the RAG app, we'll see that it's running as a non-privileged user, all those good things. But we'll take it a step further. So in trying new things, it's always good to take a phased approach. So the next thing we'd want to do is try to use ChainGuard's Python FIPS latest dev image to make sure our application still works using FIPS approved cryptography. That also was a single line of code change. We tested our application, it worked fine. And then the last phase of this, it involves just a little bit more effort, but it's called a multi-stage build. So you'll notice there's 2 from lines in our Docker file. The first line installs our dependencies, it copies in our source code, and then in the second stage, we remove all those developer tools and utilities that we don't need to run our application, we just need to build it. So it's much more minimal, which you can see in the output. So those 2 low vulnerabilities go away. It's much more minimal, so only 174 packages, 1.8 gigs, so like half the size from our first build. And it kind of checks all the security boxes there. All right, and then in summary, kind of best practices to trying to build an application that is going to be in a good position to be ATO ready. you want to build from something that's pulling in source code fresh for you. That's the quickest path to low CVEs. And being intentional about the base image that you build your application on top of is a super key choice. And then we kind of quickly looked at it, but the level of effort to try to build things from source yourself is a lot of toil, a lot of engineering work, a lot of maintenance. So probably not the line of business you'd want to get into yourself. All right, and I know there's a couple minutes left, so got some time for questions if anyone has anything. Otherwise, we will be at booth 2948, which is just right back there. And then I'm also doing a workshop tomorrow, 11:30 to 1, where we can actually build this RAG application that I talked about today. So you can run it on your laptop. You can feed it your own contextual documentation that you want and kind of play around with an AI chatbot that's secure. Thank you.
Connor, thank you very much, and thank you all for being here. Our next session will be at 11:10.